Hello students, welcome back to physics sessions. Hello students, welcome back to physics session. Yeah, today let us discuss important concepts from the electrostatic potential and capacitance. In this chapter, we are going to discuss especially potential due to system of masses, or you can say potential at a point in the field and potential at a point due to system of charges and some important topics from the capacitance. Mainly these concepts we are going to cover in this session. And one more thing, as we discussed in the previous session about electric charges and fields, that is about electric field strength. So in this, we are going to discuss relation between electric field and the potential. So mainly we are going to concentrate on these concepts in today's session. Okay. Students, for any updates, um, you can download the Spark Academy app. For any updates, you can contact the number given in the next slide actually. Yeah. So, to join us for free live classes daily, you can download the app and you can get the clarification. And in these sessions, there are daily live classes. In the session, doubt clarification, free material in the Spark Academy app. And in the sessions, we will discuss EAMCET JEE NEET related concepts, tips, and tricks. Okay, so admissions are open for 2024 to 2025 batch, classroom as well as online coaching, long term and regular batches. And mainly, recently they have launched Yuddham or Poratam um, programs. These are very, very useful for the students. Please, you can, if you are interested in, you can contact that Spark Academy. Already sessions have started. Yuddham is for EAMCET, Poratam is for BIPC students. Yes, for any updates, you can contact this number, which is given below here. 9133380172 or 8977525461. Okay, so no need to wait. Let us start our session. Yes, electric potential in the field. Imagine here, surrounding of any charge. Let the charge is Q. Surrounding of any charge, electric field will exist. This dotted line indicates the field of this charge. Okay. Now, in the field, if we keep a test charge Q naught at a point P, now this point from the charge, let it is at a distance R. Now, at this point, potential Actually, electrostatic potential is a scalar quantity. It's a characteristic point of every charge which is in the field. Now we are finding potential at that point. It should be equal to, we can write it as work done or the interaction energy between the charges which are in the field, within the field. అంటే ఇక్కడ Q naught charge should be in the field of Q. That's all. అంటే ఈ Q naught charge, if it is very far a distance, there may not be the interaction energy. If separation increases, force decreases, field decreases, automatically interaction energy decreases. So within the separation, at that point, if you are finding the potential, it should be equal to interaction electrostatic potential energy. That potential energy is nothing but doing some work to get that charge to that field separation. By doing some work, we bring this charge to this separation. That will be stored as a potential energy. That potential energy per unit charge placed at that point. Okay, so you can also define it as work done or the interaction energy. You cannot say always it is interaction, it depends upon the charges given at that point, because electric force can be repulsive or attractive. So you can say electrostatic potential energy between the charges by test charge placed at that point gives potential at that point. Okay, for example, let me give one simple example here. Field charge is, let us consider 3 microfarad. Test charge is 1 microfarad. Now I'm asking potential at 1 microfarad. Let the separation is 0.2 meter. So 1 microfarad is at 0.2 meter from the 3 microfarad. Now we are calculating potential. అంటే ఇప్పుడు నాకు పొటెన్షియల్ అనేది 1 sorry, we are talking about charge. It should be coulomb. I got into that capacitance. So charge should be measured in coulombs. Okay, so at 1 microcoulomb I need the potential. So I need to take interaction energy between them by that charge. What will be interaction energy? For that, you must concentrate here. Electric potential energy is between any two charges should be equal to K into Q1 Q2 by R. Here Q1 is 3 microcoulombs. Q2 Q naught, that is Q2, which is 1 microcoulomb. So I can say here, actually I'm writing about this example, the potential energy between them in the separation R is equal to K into Q1 is 3 into Q2 is 1. Both are given in microcoulombs. So I need to take 10 power minus 6 whole square, actually, because 10 power minus 6 into 10 power minus 6, it will become 10 power minus 12 by 0.2 meter. Yes, no? That is the potential energy between the charges. That potential energy by Q naught, I need to take by Q naught. So this equation I need to divide with the 1 microcoulomb. Then finally we will get it as K into 3 into 10 power minus 6 by 0.2, because the Q naught charge gets cancelled. So at which point we are finding potential does not depend upon the point charge. It depends always on field charge. That is what we are getting, K into 3 into 10 power minus 6 coulombs by 0.2 meters. Okay. Similarly, next come to potential of a system of point charges. At this point, due to system of charges, we need potential. Look into this formula, that is V equal to K Q1 by R1 because Q1 charge is at R1 distance from the point. At this point, whether charge presents or not, you always imagine if charge is not given, if unit positive charge present at that point. Anyway, it does not depend upon that. It always depends upon the field charge. Is it? So I can write at Q1, it should be, sorry, at P due to Q1, it should be KQ1 by R1. As it is a scalar quantity with the sign you need to substitute. Okay, as they given minus, so it should be minus KQ1 by R1 plus. Even Q2 also negative charge, so minus KQ2 by R2 plus. Q3 is a positive charge, so KQ3 by R3 plus. And Q4 again it is negative, so minus Q4 by R4, so on till till number of charges at that point due to system of point charges. Okay, let us discuss one example here. For example, along x-axis, this is origin. From the origin, identical charges, infinite number of charges. Let me say there are infinite number of charges. First charge is at 1 meter distance, it is 2 meter distance, it is 4 meter distance, next charge 8 meter distance, so on like that. Infinite number of charges are placed. Now I want potential at O due to system of charges. So you have to take it as like KQ by R. Yes, na? So K is common and of course Q also common. We will get like 1 by 1. As I given all identical charges, there is no negative sign in the negative charge along x-axis here. So directly take, anyway I took the common Q. So 1 by 2 plus, we are taking 1 by 4 as 2 square. Because for the sum of infinite terms we can use the geometric progression. So I'm considering 1 by 8 can be written as 2 cube. So on like that, so on infinite. So V at origin due to system of charges is being equal to KQ into sum of the infinite terms geometric progression first term by 1 minus common ratio. This model question already discussed about F net due to system of charges, E net due to system of charges. Similarly, V net due to system of charges. So what is common ratio in some of the terms, some of the infinite terms here? That is 1 by 2. First term is 1 only because 1 by 1 gives 1. That is what I kept 1 by 1 minus 1 by 2. Okay. Now, if you take the LCM, you will get it as 2KQ. Is it? So due to system of charges at a point, net potential this way we can find. Next come to how can we find the potential difference? Potential difference in the field between any two points. For example, we are displacing a charge Q naught. Then the potential difference from point A to point B we are displacing. Consider this is the field. At point A, Q naught charge is there. Now it is taken to point B. So it is displaced. So some work is done. Yes. So that work done by Q naught will give you potential difference. If they're asking how much work is done, if here I given symbol capital Q, if Q charge is moves, that charge into potential difference. Because in the above equation, work done should be equal to which charge is moving from A to B, Q naught charge. So this VB minus VA, which is between potential difference between points A and B. So we can write potential difference between A and B, or you can represent with delta V. which is the potential difference through which charge Q moves. Here I can say through which charge Q naught moves from A to B. And the next point, between two equal and opposite charges at the midpoint of two equal and opposite charges, net potential will be 0, but electric field will not be 0. Therefore you can say V net equal to 0 at midpoint of equal and opposite charges. If I give the distance between them is r, so from any charge at r by 2, potential is 0. But electric field intensity will not be 0, though they are equal and opposite charges. Okay. Next, already I discussed what is electric potential energy. So within the separation, the electrostatic potential energy will be equal to K Q1 by Q1 Q2 by R. From that only we can write potential, which is equal to work done by test charge, which is placed in the field. Actually here they consider test charges with the symbol capital Q. Previously in my example, field charge I consider capital symbol and test charge I given like Q naught. So no need of confusion here. We need to take which charge we are placing in the field. That charge we need to take here. This work done only will be stored as a potential energy. So potential energy by that test charge. Let us try few questions about, we can also find potential energy, net potential energy due to system of charges. Due to system of charges. Let us look into that. Yeah, you can see here electric potential energy. For example, here Q1, Q2, Q3 are at certain separation in this system, which is triangle. So Q1, Q2, Q3 charges are placed at the corners of a triangle. Then what is the net potential energy of the system? You can say it is net potential energy. Whereas we write KQ1 Q2 by R, K value is always in the electrostatics, it is 1 by 4 pi epsilon naught, it can be taken as 9 into 10 power 9. Yes, so 1 by 4 pi epsilon naught is common. First, between Q1 Q2 separation R1 2, so you can write Q1 Q2 by R1 2, Q2 Q3, so Q2 Q3 by R2 3 plus Q3 Q1 by R3 1. Okay. So this way we can find the net potential energy. All of you look into this diagram which kept in the box. I want the net potential energy of this system where equal charges are placed at the corners at the same distance. Nothing but this system is equilateral triangle. Okay. So net potential energy of this equilateral triangle system. Simply I can say here unit value of this system. Actually I given that question here. See, three particles each having a charge of 10 microcoulomb. Yes, no? 10 microcoulomb are placed at the corners of an equilateral triangle of side 10 centimeter. The electrostatic potential energy of the system is. So here I am writing, actually diagram was given above of this question. Look into that diagram, U net value, whereas charges equal, distance equal. So between these two will become Q1 Q2 by R. Same charges, no? So you can say Q square by R. Next also Q square by R. Between these two, next to between these two, next to between these two. Sidewise. Yeah. Can we write? 3 times of kq squared by r. And you can observe here energy is given in joules. So I can write 3 into k value, need to take it as 9 into 10 power 9 into q square. Q is given 10 microcoulomb. So 10 into 10 power minus 6. Micro is 10 power minus 6 whole square by distance is given in centimeters. So convert into meters. Because standard unit of distance is meter, standard unit of charge is coulombs. That is what we are converting the values. Then only we get energy in the standard system, which is in joules. Okay. So let us write here. Um, First reduce the powers, and with the numerical portion we are getting 27. It is 10 power 9 or 10 power minus 12 into 10 square. We get 10 power minus 10. Yes. And here remaining 10 power minus 1. Take it up. It will become 10 power 10 with plus 9, because minus 1 will go up as plus 1. So plus 9 plus 1 becomes 10 power 10, and in the bracket value remaining value is 10 power minus 10, plus 10 minus 10. So power values are cancelled, only we are getting 27. So answer is 27 joules. Next, let us try this question about electrostatic potential. As shown in the figure, charges plus q and minus q are placed at the vertices B and C of an isosceles triangle. The potential at the corner A, actually that is the question. We need to find potential at the corner due to remaining charges. That is the meaning. You can observe the figure here. It is an isosceles triangle. So when we are finding potential at this point, so potential at A should be equal to potential due to corner B plus potential, net potential like V1 plus V2 plus V3, so on that way. Yes. So at that point should be due to B and due to C. So to write potential at any point, it should be in the form of K, Q, I can say capital symbol here, KQ by R. This is the field charge, means due to which charge we are finding that charge. Like due to B means I need to take plus Q, due to C means I need to take minus Q. At A, whether the charge present or not, it does not depend upon that. Yes, no? Now, you can observe between A and B, the distance will be from this right angle triangle, as it is being hypotenuse, it should be under root of A square plus B square. Now, at this point, due to this charge is at separation under root of A square plus B square, and this side also I can say same. Equal charges. So from the point now, B and C are at equal distance and opposite charges. Just before we have given one question, one point between two equal and opposite charges at midpoint, V net value 0. Directly you can answer 0. Or else if you are taking V due to B, you can apply this point, or you can say V due to B at point P should be equal to K into plus Q by under root of A square plus B square plus K into minus at C, due to C at point P minus K by minus Q by under root of A square plus B square. So denominator value same. In the numerator, KQ minus KQ, we get 0. Is it? Next come to Relation between electric field and potential. Between electric field and potential, if potential varies with the distance, then electric field equal to minus dV by dr. Okay. It is unidirection. If unidirection is given, might be x direction, y direction, z direction. Three-dimensionally given, how can we find electric field where the potential varies along x, y, z? It should be equal to Ex into I cap plus Ey into j cap plus Ez into k cap. What is Ex here? It is minus dV by dx. So potential varies along x plus minus dV by dy into j cap plus minus dV by dz into k cap. Then you can measure the electric field vector where potential varies along x, y, z. Okay. Next, if a field varies with the distance, to find the potential, we have to follow the integration. That is integral minus, because field is negative gradient of potential. So from this only, if a field varies, to find the potential, actually it should be integral dV, which gives you net potential, equal to minus integral r1 to r2, means the distance from r1 to r2, E bar dot dr bar can be written as like a dot product E dr cos theta. So in general, relation between, for constant field and potential, relation between electric field and potential is E equal to V by D, where V is potential difference, D is distance between the points, E is field strength or electric field intensity. Let us try few questions about electric potential. It is one of the important topic in this unit. So one easy and moderate question. Determine determine the electric potential at 0.01 meter from a charge of 2 picocoulomb. Pico means how much? That value we need to substitute here. Yes, no? I can write here from 2 picocoulomb at a distance, means at this point, that point is at what distance? 0.01 meter, sorry, 001 meter. So at this point, potential at this point from 2 picocoulomb charge should be equal to K into that 2 picocoulombs by 0.001. You need to substitute it as 9 into 10 power 9 into 2 into 10 power minus 12 by, because picocoulombs we are converting into coulombs, by 0.01. It should be equal to 18 into, reduce the powers, 10 power 9, and it will give you 10 power minus 3. Take it up, it gives you 10 power plus 12, because minus 3 will go up as plus 9, no, plus 3 becomes plus 12. Already here minus 12. So we get 10 power 0. Finally, we are getting 18. Potential at that point is 18. Okay. And let us try this question. Two charged particles are placed on the x-axis of a coordinate system. The first charge, the meaning first charge, Q1 equal to 2 into 10 power minus 6 coulomb is at the origin. The second, which is Q2 equal to minus 5 into 10 power minus 6 coulomb, is at x equal to 1.0 meter. So I can say here first charge is here at the origin only along x-axis. That is 2 into 10 power minus 6 coulomb. And from the first charge, at 1 meter distance, minus 5 into 10 power minus 6 coulomb charge. is at 1 meter distance. Now they're asking determine a point in between these two charges where the electric potential is 0. We know that if equal and opposite charges, you can say at midpoint V0. But these are not equal charges. They're at certain separation. At somewhere it will be 0, not exactly at midpoint. So what is that point you need to find? So I'm taking mm, from the 2 into 10 power minus 6 charge, let that point where potential is 0, that point is considered as a neutral point actually. So now this neutral point is considered as x distance from 2 into 10 power minus 6 coulomb. And what will be remaining distance? That is minus 5 into 10 power minus 6 charge is at 1 minus x distance. So now we got, so potential at that point, which is at the neutral point, is equal to due to this charge and due to this charge, is it? So can I write 2 into and k also there, 2 into 10 power minus 6 by x plus uh, k into minus 5 into 10 power minus 6 by 1 minus x, like v1 plus v2 due to first charge and the second charge at that point. And at that point we are saying potential 0. So equate with 0, because they're asking determine point in between these two charges where the electric potential 0. And we can write it as, actually after equating with 0, I can write direct step but simplifying like this. It will become minus k into 5 into 10 power minus 6 by 1 minus 6. So I'm taking first term LHS side. So now it gives you k into 2 into 10 power minus 6 by x is equal to mm, k into 5 into 10 power minus 6 by 1 minus x. So both side k cancel, 10 power minus 6, 10 power minus 6 cancel. Then do the cross multiplication, find the x value where the potential is 0 from. I consider that distance is from 2 into 10 power minus 6. Okay. From the first charge, I consider from the first charge. That is the meaning. So find x value. So we can do the cross multiplication. It will give you 2 minus 2x is equal to 5x, 2 equal to 7x, then x is equal to, it will be 2 by 7. 2 by 7 means it gives you 0.29 exactly. Finally, I'm writing here, therefore, where the potential is 0 from the first charge means I can say it is 0.29 meters. If they're asking from the second charge, at what is that distance from the second charge where the potential is 0? 0.29 meters from first charge, and it will be equal to 1 minus 0.29 from second charge. The options can be given that way also. Okay. Next, look into the capacitance. సో ఎలక్ట్రిక్ పొటెన్షియల్ నుంచి కంపల్సరీగా మనం ప్రాక్టీస్ చేయాలి అంటే పొటెన్షియల్ ఎట్ ఎనీ పాయింట్ అండ్ పొటెన్షియల్ డ్యూ టు సిస్టమ్ ఆఫ్ చార్జెస్ అండ్ potential where the potential is 0 from one of the charge, like that just before question. ఆ మోడల్స్ కంపల్సరీగా చూడాలి. ఓకే. Now capacitance, the circuit symbol of capacitor is like this. we know that across the capacitor, equal and opposite charge is distributed. The charge resides over the surface of the plates. And if uh, if the capacitor is getting charged by Q, its potential will increase. Or we are charging the capacitor by providing the potential difference. Charge will displaced. So both are directly proportional. Charge across the capacitor will be proportional to potential difference across it. Okay, while charging the capacitor, it always maintains the constant potential difference. Okay, from this relation we can write charge across the capacitor, nothing but it's the magnitude of charge, will be equal to capacitance into potential difference. If we are writing capacitance of from this equation, you can say capacitance of a capacitor will be charge by potential difference. If we are writing for parallel plate capacitor, parallel for parallel plate capacitor, it is equal to epsilon naught into A by D. When there is no medium between the plates, parallel plates means we consider like this, which are having area of cross section A. Two plates are at certain separation, that is D. D is separation between the plates here. If no medium present between them, then the capacitance of this parallel plate capacitor will be equal to epsilon naught into A by D. Here epsilon naught is what? Electric permittivity in the free space. Free space means no medium present. Okay. And similarly, if medium presents, C dash will be equal to epsilon naught into A into that medium value, K. K is a dielectric constant or the medium constant value by D. With the medium, between the plates if there is a medium. And come to energy stored in a capacitor. You know, energy stored or released, I can say. So, by providing the potential difference across the capacitor, means while getting charged, some work will be done by the battery. I can say work done by the battery, which we are providing the potential to the capacitor. Work done by the battery will be equal to Q into V. This work done only will be stored as energy in the capacitor, but not the total work will be stored as a energy. Half energy will be stored, half energy will be released in the form of a heat. So sometimes they can ask you calculate the heat energy while the capacitor is charged. అంటే మనం కెపాసిటర్ని ఛార్జ్ చేసేటప్పుడు అది ఎంత ఎనర్జీని రిలీజ్ చేస్తుంది లేదా స్టోర్ చేసుకుంటుంది. కెపాసిటర్ అనే ఎలిమెంట్ దానికి ఒక కెపాసిటీ ఉంది, ఎనర్జీని స్టోర్ చేసుకునే కెపాసిటీని. అంటే ఆల్ ఆఫ్ సడన్ బ్యాటరీ రిమూవ్ చేసేసి ఆ ఎలిమెంట్ని అగైన్ ఎలక్ట్రిక్ సర్క్యూట్లో కనెక్ట్ చేస్తే లాస్ట్లీ ఎంత ఎనర్జీ స్టోర్ అయి ఉంటుందో ఇట్ విల్ స్టార్ట్ ఫ్రమ్ దట్ ఎనర్జీ. Okay, so capacitance has the capacity to store the energy in it. How much will be stored? How much work done will be done by the battery? From that, half energy will be stored and remaining half will be released as heat in the form of heat energy. Okay. So energy stored in a capacitor U equal to half CV square, which is equal to, actually these are the different modifications. Half CV square and is equal to half QV and is equal to Q square by 2C. Using these relations, energy stored or released by the capacitor will be equal to CV square form, half QV form, Q square by 2C form. If they're asking energy density, that energy stored or released by volume. Volume means we need to express in terms of area of the plates and distance between the plates. Okay, which also equal to half epsilon naught into E square. Because equal and opposite charge resides over the plates of a capacitor, electric field will be created between the plates. It is always from positive to negative. Okay. So energy density we are expressing in terms of the electric field which is created between the plates due to opposite ions. Half epsilon naught into E square. Next in important topic in the capacitance, combination of the drops. Drops nothing but charged drops like a spherical shape. And in the combination of the drops, if these drops are combined to form a big drop, for example, we are having the smaller drops, n small drops, and consider n small drops, radius small r. Okay, uh, these n small drops charge across each drop is q, and they combine to form a bigger drop usually in a spherical shape no, of the radius r. Then the charge of this big drop should be equal to number of small drops only na. So in this situation, in the combination of the charge drops, if n small drops are combined to form a big drop, the new values after new values means these are about bigger drop, new values of big drop. Now they're asking what is the charge of a big drop. It should be equal to n times of the smaller drops charge because n drops are combined. And relation between radius of the bigger drop and the smaller drop, that is r equal to n power 1 by 3 into r. You know, in previous years, in NEET and EAMCET, there are questions, direct these relations as a question. So formula wise, as a direct question, we can expect these relations. Now, C equal to means capacitance of a bigger drop is equal to n power 1 by 3 times of capacitance of a smaller drop. Because n smaller drops capacitance we are taking C, bigger drop capacitance we are taking capital. Similarly, potential. Potential difference of a bigger drop should be equal to n power 2 by 3 times of potential of a smaller drop, and the potential energy which is equal to n power 5 by 3 times of U. Okay. Next. Important topic in the capacitance, grouping of capacitors, nothing but combination of capacitors. Let us look into this diagram which gives the series combination of capacitors. It is parallel. Series combination means end to end connection. When capacitors, here I consider three capacitors which are connected in series. uh, ch- uh, when they connected in series, charge remains same ఏవైనా నెంబర్ ఆఫ్ కెపాసిటర్స్ లేదా టూ కెపాసిటర్స్ తీసుకోండి, మోర్ దాన్ టూ, యూ కెన్ కన్సిడర్ మోర్ దాన్ టూ ఆల్సో. అవి సిరీస్ కాంబినేషన్లో ఉంటే అక్రాస్ ఈచ్ కెపాసిటర్ ఛార్జ్ అనేది సేమ్ ఉంటుంది. సో ఫస్ట్ కెపాసిటర్ ఛార్జ్ క్యూనే ఉంటుంది, సెకండ్ కెపాసిటర్ క్యూనే ఉంటుంది, థర్డ్ కెపాసిటర్ ఆల్సో క్యూనే ఉంటుంది as they connected in series. But potential is different. So potential difference across the combination should be equal to V1 plus V2 plus V3. V1 is across first, V2 is across second, V3 is across third capacitor. Yes, na? So now if we are taking equivalent capacitance for two capacitors, we can write more than two also. For two capacitors, C equivalent will be C1 C2 by C1 plus C2, because if I am taking equivalent from this equation, it should be 1 by C1 plus 1 by C2. If there are more, you need to take 1 plus 1 by C3 plus 1 by C4, so on like that. So from this equation, you can say for two capacitors, it should be C1 C2 by C1 plus C2. Okay, and we know that Q equal to CV, where C is the in this case, to find the total charge, it should be equal to equivalent, C equivalent into V. And we know that charge is same, so from here we can say capacitance or the potential difference is inversely proportional to capacitance. Both are inversely proportional. So whenever we are given with two capacitors, if they're asking potential across the first, here one logic you can apply. Actually, it should be C2. Here it should be C1. Yeah, look into this. Whereas both are inversely proportional, when you're finding potential across first capacitor, opposite capacitance by total capacitance or sum of the capacitances into net potential. Because in this combination, how much potential is provided they can give. We are finding that potential will be divided across each capacitor. That is V1, V2. So when you are finding V1, you need to take opposite capacitance by sum of the capacitors into V. Similarly, V2, opposite capacitance for the second should be V1, so should be C1. Sum of the capacitances means C1 plus C2 into V. V is the total potential difference across the circuit. And lastly, I have given, so when there are two capacitors, this simple logic you can apply to find the potential difference across each. Last two formulas for identical capacitors means first capacitance value C only, second capacitance also C only, third capacitance also C. Like that. If there are identical capacitors in series, then C equivalent is C by N. If there are three, you should say it C by 3, equivalent value. If there are two, C by 2. If there are four, C by 4. Like that, N, C by N. And potential across each capacitor for identical, it should be V by N. Total potential difference by number of capacitors. Come to parallel combination. So two ends of the capacitor connecting to other capacitor two ends, and these two ends connect to other capacitor two ends. This combination is parallel. Okay, across the combination, if V potential difference is applied, it will be same. Across same potential difference will be maintained across the each capacitor if they are connected in parallel. So potential difference will be same, but charge is different. Charge across the each capacitor will be different. So that total charge should be equal to Q1 plus Q2 plus Q3 if there are three capacitors. Then equivalent for the parallel combination, if there are three capacitors, it should be C1 plus C2 plus C3. If there are two capacitors, C1 plus C2. Whereas charge is different across each capacitor, for two capacitors, In the circuit, there are two capacitors which are connected in parallel. Now I'm finding charge across the each capacitor. Same logic you can apply. From this equation you can say whereas potential difference is same, Q is directly proportional to capacitance of a capacitor. So I want charge across faster. So it's the capacitance by sum of the capacitances into total charge. Okay, that is net charge. With this potential difference, this total charge, it will be distributed across each capacitor, na? So we are finding the distribution of charge. Q2 will be its capacitance, that is C2 by sum of the capacitors into net charge. And come this side, for identical, for identical capacitors means all the capacitors are having same capacitance value. Here C, here C, here C. Then the equivalent of that parallel combination will be n times of C. If there are three capacitors, 3 into C. If there are two capacitors, 2 into C. If there are five capacitors in parallel, 5C. If they are identical. Like that, n capacitors, n times of C. And charge across each capacitor, whereas charge distribution is different in parallel combination. So across each should be that total charge by number of capacitors. Okay, students, as you all have known about these programs, Yudhamar Proratam, they have launched with very reasonable price, that is very lowest price. You can contact for any information at the Spark Academy. So the key features, everything you all have known. Mainly look into Spark Academy, why it is different from other means this point, this point, and this point especially. And the remaining key features you can see there are daily live classes solving all your doubts in the class and interaction, live interaction, shortcut methods, study notes will be shared, doubts clarifications, special workshops during festival days, and every time we focus on the previous year's questions and important models. And the methodology, basic concepts, shortcut methods, all model questions, exercise questions, previous year's questions, chapter wise tests, weekend test, grand test, and the analysis can be given. And you can contact for any updates what are provided the numbers below here for admissions for any enquiry. Yeah. So about today's topic, let us try few questions. Which are the important models of today's topic? The electric potential V at any point x comma y comma z in space is given by V equal to 4x square volt. The electric field at the point 1 meter, comma 0 meter, comma 2 meter in volt per meter is. They're asking electric field equal to how much, whereas potential is varying only along x direction. So unidirection. So to find the electric field, we can take here minus dV by dx. So differentiate. Actually, the given points coordinates along x, y, z, 1 meter, 0 and 2 meter. Yes, no? Minus dV by dx, it should be equal to minus of its differentiation will become 8 into x. So we need to put at x is equal to 1, it gives you minus 8. So in the given options, minus, because electric field is always a negative gradient of the potential. Okay, and potential is varying only along x-axis, so field also will be in that direction, that to negative. So you can say 8 along negative x-axis. That should be the option. Okay. Next, if the potential function is given by V equal to 4x plus 3y, then the magnitude of electric field intensity at the point 2 comma 1 will be. Oh, they're asking magnitude of electric field intensity. Here, potential is varying along x and y. Means x and y values changes, definitely potential changes. So you need to take first of all electric field vector, which is Ex into I cap plus Ey into j cap only, because potential is only along x and y. So now Ex should be equal to minus dV by dx. Yes, now? So Ex should be equal to minus dV by dx. Ey should be equal to minus dV by dy. Then minus dV by dx, with respect to x differentiation, we will get minus 4 into I cap plus minus 3 into j cap. But they're asking magnitude of electric field intensity. Magnitude means under root of x square plus y square, that way. I think we are getting 16 plus 9, it gives you 25, which will be equal to 5. So magnitude of electric field intensity is 5. Um, Students, you can try these questions. So please write down. Those who have followed the session from the given topics, today's related topics, try these questions. After charging a capacitor of capacitance 4 microfarad up to a potential 400 volts, its plates are connected with a resistance of 1 kilo ohm. The heat produced in the resistance will be, we are given with the capacitance of a capacitor and the potential difference. They're asking heat produced, nothing but how much energy is released. You can take directly U equal to half CV square. That is the clue. Yes. Now look into combination of capacitors. How can we measure equivalent capacitance value? We are given with the three capacitors which are arranged in a triangle system. So how can we find the equivalent? First of all, find reference points. Okay. So give the directions this way. From that reference point, always take the element which is farther from that. So first solve these two capacitors equivalent. How they connected? They are in end-to-end connection. We are identifying points of in that system. From that point, farad element equivalent we are finding first. Okay. What is as they are in series? Can we say 3 into 6 by 3 plus 6? Two capacitors in the series. So C1, C2 by C1 plus C2. So it will be 18 by 9. It gives you 2. Now this combination and 3 microfarad will be parallel. This combination is 2 and 3 microfarad are being parallel. So final equivalent of that combination will be equal to 3 plus 2, which is equal to 5 microfarad. Okay. Come to this diagram. These are the special diagrams. You can observe identical capacitors are connected between A and B terminals. And you can see in this diagram that reference points, like potential difference points A and B, they're connected directly, no element present between them. If the terminal points are connected directly, you can say here means um, it will flow along this path only, the charge. No energy received by the element in the system. Total energy will flow along this path from this terminal to this terminal along this path. But there is no element present between the terminals. So you can say short circuit. It is in the short circuit. So equivalent 0 because no energy received or stored by the element in this system as initial and final points of the system connected directly. And one more circuit which is in the short where the element is in short circuit. You can see here also three identical capacitors. So if you are taking this is high potential point and low potential point, which are the reference points of this system, and this capacitor, two ends connected to the same potential. So it is in short circuit. No charge flow, no energy stored in it. That is the meaning. Short circuit means. So then the equivalent system will be after if the element is in short circuit, you can say it can be removed. No charge displaced, no potential difference because of no potential difference across that. So no energy can be stored in it. So here you can say finally equivalent is with these two only. So two capacitors now they are being in parallel. The two equivalent capacitors, can we say it is n times of C, which is equal to 2 into C. So that is the equivalent of this circuit, is it? And we know capacitance of a capacitor, if no medium presents, it can also be written as 2 into epsilon naught into A by D, where D is distance between the plates, A is area of the plates. Anyway, they are identical capacitors, so dimensions will be same. So, okay, students, so these are the important topics of today's session. You can practice as per the topics. Any doubts we can discuss within the live session in the next session. Okay, thank you, students. And please don't forget, students, please like, share, and subscribe this.